Okay, looks like we're back again.
Yeah.
Okay. Beatriz, you said there were some things in the chat, so let's go through those before I go on.
Yeah. There is an answer from Cecilia Apa about your question, short-term versus long-term decisions. She says, I think that there comes a time where long-term consequences turn into short-term consequences. Mm-hmm. So you have no choice. You have to pay your debt in order to survive.
Yes, that's true. That's true. And with technical debt, I think, yes, that often happens. You know, you put it off and put it off and put it off. But the risk then is you get to the point where it's too late to pay it off. And the debt has become too big. That happens with financial debt too. People go bankrupt, right? When they have too much debt. That's true. Good point.
So we have also two questions. One of them is from Elvio Geronimo Jr. He says, I like that you reinforce what is not technical debt. This is really interesting because it is still misconception in the community. And the question is related, based on your research, what are the main difficulties in managing debt in software organizations?
What are the main, what?
Difficulties.
Difficulties. In, what is the rest of the question?
In managing debt in software organizations.
Okay. So, yeah, there are a bunch of difficulties. But some of the big ones, I think a very general difficulty in managing technical debt is communication, because technical debt is something that's not purely technical. There's a business side to it. How many times have I talked about money? Okay. And managing customers, which is something that software developers are not always very good at. But managers and product owners and company owners are not very good at the technical part. So managing technical debt and making decisions really requires a really, really good communication. And a lot of research has gone into helping to facilitate that communication, especially visualization techniques. There's a really interesting project actually there in San Jose in Costa Rica. Alexia Pacheco, who's a PhD student at the University of Costa Rica, is working on using Sankey diagrams to help facilitate that communication between different stakeholders. And that's really, really interesting. So I'm watching that to see how that goes. I hope that works well. But there have been other projects that have looked at different types of visualizations that are meant to be understandable by non-technical folks as well as technical folks. So I think communication is probably the biggest difficulty. That's a very broad category of difficulties. But the other difficulty is just the uncertainty, because you don't have a set interest rate. You don't have even a set principal sometimes. So it's hard to know what technical debt is important, because lots of technical debt just goes away when a module or a class is retired.
Okay. So I have another question about Giovanni Diane Rotoli. It is due to the gap between academia and industry, what techniques are the most used today in the industry for systematic technical debt management? How much evidence is there about it?
Yeah, that's the huge question, right? I don't think we know what are the most common techniques, because I don't think any researcher has that broad a view of the software discipline. So the closest we get is there are a couple different projects. One that stands out is the Insight TD project, which is based in Brazil. Rodrigo Spinola is the main investigator there. But it's a survey study of software practitioners, but it's been replicated all over the world. And I think last count, something like 13 different countries all over the world. And it asks, that's where some of these results come from, because it asks practitioners about causes and effects of technical debt in particular. So that is the best way to get a broad view, and probably the data from that kind of a study that's replicated in all kinds of different organizations all across the world. You get the broadest view, but of course it's a survey, so it's limited. You can't go so deeply into it, and you have to interpret people's answers. But from that, that's where a lot of these decision factors come from that I talked about a slide or two ago. But that doesn't make sense to use that as a way to know what are the most common practices. It tells us what the breadth of the practices are, but doesn't really tell us what most people are using. So we don't know, and that is a problem between the gap between industry and academia, because lots of academics do work closely with industry, and that's fantastic. But any particular research group can only work with a certain number of companies. And so their view of the software industry is somewhat limited by who they work with. So no, it's hard to get a broad view.
I agree with you. So continue with your tutorial, please, Caroline.
Sure. Okay. So what I'm going to go do now is go back to those 4 types of software development decisions, not technical debt decisions, but other types of decisions, and see if we can take some of these things that we've learned about technical debt decision making and see if we can apply it in these other areas. So the first one is backlog prioritization, where you're deciding what things in the backlog you're going to do next. So one of the findings was, for technical debt decision making, a simple cost benefit approach doesn't work. And just as a thought experiment, I thought, that's probably going to be true for backlog prioritization too. We also have uncertainty in the backlog, less so than technical debt, I think, but there's some uncertainty. There certainly are interrelationships between backlog items, and there are ways, there are techniques for managing those interrelationships. But costs and benefits are complex to evaluate because it does have to do with market factors. It does have to do with effort estimation, which we're still not too terribly good at. So probably a simple cost benefit approach is not going to work for backlog prioritization, just as it didn't work for technical debt decision making. It seems like pretty much the same decision factors are at play. Certainly cost is something to look at in backlog prioritization. Expected changes, maybe not so much. But again, even when you're looking at the backlog, you're trying to look to the future. What kinds of things are going to become important? Certainly time pressure. How much you take off the backlog at one time has to do with time pressure. Risk, in particular, looking at technical debt, what's risky to not pay off, and the available resources. Of course, that's probably the most important decision factor in backlog prioritization. So choosing items that are visible to the customer. So this is something we learned about in technical debt decision making. This seems to make sense for backlog prioritization. If you want to choose things that are visible to the customer, then you're going to choose the defects, the actual defects, especially big defects, and new features that customers want. Okay, because you want to make the customers happy. You want to alleviate any pain that they're feeling from defects. So that makes sense that this applies to backlog prioritization too. Building prioritization into the process. Now, there are some ways to do this that some projects are already doing. It may not solve the backlog prioritization problem, but it could help. There could be policies put into place about the balance between in any particular iteration or sprint. You have to have a certain percentage defect fixing, a certain percentage new development, a certain percentage TD repayment. So having a policy like that takes away some of the decision-making pressure. So that's helpful. Also, having good processes for evaluating the severity or the urgency or the importance of a backlog item up front when you put it on the backlog, that's very helpful and makes the decision making a lot easier. Of course, it's context dependent, and especially in terms of the role of the customer. Okay, so let's do the same thing about design decisions. So a cost-benefit approach for design decisions, it could help, especially making choices about architecture and frameworks and infrastructure, weighing the costs and benefits of different architectures, but a lot of the costs and benefits probably are not going to be quantifiable. Some of the decision factors seem relevant, but some of these decision factors that we found for technical debt decision making, you don't really know up front when you're making these architecture decisions. So they're not going to really work, like expected changes. Risk is hard to get a handle on up front. Things that are visible to the customer. Not sure about this one. So how do you take into account what's visible to the customer when you're making design decisions? I couldn't think of a way, but maybe you can. So here's a green box for you to think about and put something in the chat if you come up with something. Building design into the process. Well, it's always good to have a good design process, but probably what's even more important is just whatever process you use for design, that you have the right people at the table, okay? Design in a vacuum, so a design without people who represent customers, who represent markets, who represent the business side is hard to do. And context dependence, obviously depends on the role of the customer, maturity of the process, all these kinds of things is true for design decisions as well. So what about testing? Does this work for testing? So simple cost-benefit approaches will not work for testing either, because it's all about uncertainty. Uncertainty is especially high when you're making testing decisions, because the whole point of testing is you don't know how many defects there are, or if there are still big defects, or if there's still major defects or showstopper defects. All of that is uncertain. So doing a cost-benefit analysis for when to stop testing is going to be really, really difficult. Decision factors. So decision factors for testing, certainly about time, pressure, and risk. So time pressure, how soon do you have to release? Risk is what is the risk of leaving in major defects. So some of these make sense, but some of them don't. Focus on what's visible to the customer, which when you're talking about testing, that means you prioritize testing strategies that reveal customer visible defects, okay? Which sometimes would include acceptance testing. And so that would be part of the lesson learned here. Okay, testing decisions being built into the process. Well, I guess that means having a testing process with predefined thresholds and strategies. Then you don't need to make that decision each time, each release, if you decide ahead of time what your policies, what your testing policies are going to be. And of course, it's context dependent. Again, primarily, the big piece of context is the customer relationship here. So process decisions. Let's see, we're almost out of time. You know what? I'm going to skip this one, even though I have a question here for you. So let's skip just to the point, because we're almost out of time. So the point is that decision-making happens all over the place in software projects, all kinds of different decisions, both at the project level as well as the organization level. Most of these decisions are at least partially analogous to technical debt decisions, okay? And I would argue that technical debt decisions are in fact the simplest of software development decisions, because that trade-off between short-term and long-term is so obvious and much clearer than in many of the other types of decisions. But that's debatable. So I'm curious what you think. Do you think that technical debt decisions are the simplest software development decisions of all the decisions we talked about? So I also think that software development decision-making has not been studied sufficiently. It's not a hot topic in software engineering research, and I think it should be. But some researchers are starting to learn things about technical debt decision-making. At least in the last few years, we've focused specifically on decision-making about technical debt, and we've learned some things. And those things we've learned about technical debt decisions can be a starting point for learning about decision-making in software development in general. So which brings me to what I think the future research direction should be for software engineering decision-making, beyond technical debt decision-making, for software engineering decision-making, is to start with some of these things that we've learned in the past few years about technical debt decision-making, We also need to look to other disciplines, particularly economics, because technical debt is a metaphor, but software development in general is much more about money than we like to think. It's much more about economics. And certainly there are software engineering research areas like software engineering economics, value-based software engineering, and these go back decades. People have started looking at this a long time ago, but I think it's time to go back and update those fields, to look at what's being done, and to pay particular attention, and in particular, looking at that intersection between economics and software development is really important. Now, there's a whole software engineering research community that's not in computer science, it's in information systems, that is doing a better job of this. So there are pockets of it happening that we need to pay more attention to. But the goal here is to support practitioners in making effective decisions that result in software projects that are more efficient, more effective, and that produce higher quality software. So that's always the goal, right? Efficiency, effectiveness, and higher quality, okay? But I think we need to focus more on the decisions that are made to get there. All right. So what do you think for the last few minutes? Any last questions or comments or ideas that you have, please put in the chat and Beatrice will let me know. And just while you're doing that, just so you know, at the end of these, I have a ton of references. So, and I assume we can make these slides available.
Yeah, thank you, Caroline. Some people also asked for some reference, so here we have it. We have a couple of questions of the chat, and also I have one question. So first one is from Andre Portela. He says, people from Agile world strongly advocate for the Boy Scout rule to refactor code frequently and in small steps. Is there research trying to answer why it's so hard to start using it in some cases? There are something that explain that?
Yeah, I think in many cases it has to do with time pressure. So you go into a piece of code to make a change, but you don't have much time to do it. So you do it as quickly as possible. And that usually means you leave the code pretty ugly and messy. So I think time pressure, I don't think it's that developers don't want to do it. I think developers that I've talked to feel very guilty about leaving code ugly and messy, but they just are not given time to do it. So I think that's about time pressure.
Okay, thank you. There is another question from Cecilia. Do you have any advice regarding technical debt management for projects who work with low-code development platforms like OutSystems, Salesforce, Nexus?
Right, so low-code development, yeah. That no, I don't, to be honest. That's not an area I've looked at all. And I think people are still trying, other researchers are trying to define what technical debt means in that kind of environment. At a theoretical level, it means the same thing, but what does it actually look like and how do you detect technical debt in that environment? It's a great research area, but no, I don't have any advice at this point.
Okay, and the last question, I have one question. I really enjoy the tutorial. I learned a lot of things also. You explain how to manage this technical debt, what is meaning with the technical debt, what is not the meaning of the technical debt. In order to manage the technical debt, you need to have a lot of knowledge about management of projects, design, testing, investment, and so on. So there is few people that know that has this amount of knowledge. And wondering what happens with the transfer of knowledge. There is a repository, there is something that we can reuse, because when you are starting a project, you don't know that you need to keep in mind the technical debt, that you don't have this knowledge. So how we can access to this big amount of knowledge?
Right, so I think most of it falls on the project manager. But two things. One is a good project manager always brings in other people and they don't make decisions by themselves, which I think is a really good rule for any kind of manager. It requires a lot of different people with different expertise. And that's true in software engineering in general. You need testers, you need architects, you need requirements analysts, you need systems analysts, et cetera. And that's true for decision-making and managing technical debt. But the other thing too is that's part of the role of researchers is to document the experience and the lessons learned from industry and package them and publish them in a way that's accessible to other practitioners. So that's partly our job. And that's why I'm so happy to see so many studies in the last couple of years that are case studies, interview studies, studies where we really are capturing that expertise and experience. So there are, you'll see in the references, there are a few papers that are starting to do that. And I think we'll see more of that in the next few years.
Yeah, maybe next years we have a repository with all this knowledge. Yeah. So thank you, really thank you very much for your talk. I enjoyed a lot, and I think that all the people in the chat also enjoy a lot. Thank you, and a big applause for you.
You're welcome. Thank you for the opportunity. I really enjoyed this.
Thank you.
And for the next of the people that are connected, remember that we come back at 10 of Costa Rica time for the next tutorial, and then at 1 for Costa Rica time for the Luis Orsina tutorial.